Hi ladies, this is Mrs. Blaufuss and this is geometry. It's 4.6 and it's about congruent triangles. So this whole chapter we've been working with congruent triangles. And in the last lesson, remember or the last two lessons, we looked at a few shortcuts to prove triangles were congruent. And in the last lesson, we went through some actual examples of that, of how we know those shortcuts work and how we know some of those don't work. So here are some shortcuts that work. Shortcuts for shortcuts to show two triangles are congruent: side, 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 angle, side, where the angle is an included angle, angle, side, angle, where the side is an included side, and side, angle, angle. And then angle, 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 and side, side, angle, those do not work. Those are not valid shortcuts. They do not prove that triangles are congruent. They don't prove that triangles are not congruent, they just don't prove that they are. They could be, but they don't have to be. Alright, so this conjecture that we have for this lesson stems from the definition of congruent polygons, and this you're going to see abbreviated as CPCTC. So it says if two triangles are congruent, then the corresponding parts of those congruent triangles are congruent. So this, again, you're going to see it abbreviated as CPCTC. That means corresponding parts of congruent triangles are congruent. In order to use this conjecture, you need to first prove that the triangles are congruent. And you can do this. You can show that the triangles are congruent either by using any of those shortcuts. So by side, 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 angle, side, angle, side, angle, or side, angle, angle. Again, you cannot prove that triangles are congruent by using angle, 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 or side, side, angle. Those are not valid shortcuts. All right, so let's look at this example that's on your note sheet. So it says AD is congruent to BC in the figure to the right. We're going to use a deductive argument, meaning we know one thing, then we know the next thing, then we know the third thing, to explain why the triangles, or we're looking to see that AD is congruent to BC, and we're going to do this by using a deductive argument. So why we know what we know. Right, so we know angle A is congruent to angle B, that's marked in the figure. We know AM is congruent to BM, that's marked in the figure. And then the third one has angles marked, but it does not, angles 1 and 2 marked, but it does not say that they're congruent. So let's look at those two angles. Do we know they're congruent, or do we not know that yet? So even though it's not marked, we know that these two angles are congruent because angle 1 and angle 2 are vertical angles. So if angle 1 and angle 2 are vertical angles, and all vertical angles are congruent, that's our definition, part of our definition of vertical angles, it means that those two angles are congruent. So now let's look at the triangle. Let's look at triangle AMD. And let's look at triangle BMD. Now, when you're writing congruent triangles, you have to make sure that the corresponding parts match up when you actually write it. So angle A is congruent to angle B, so that's my first letter. Angle M is congruent to angle M, that's angles 1 and 2. So that's my second letter. And then the third letter of the triangle is D and C. So those are going to match up. Those should actually be A, M, D, and B, M, C. So we have an angle, a pair of angles. We have an included side, and we have another pair of angles. So these two triangles are congruent because of angle side angle. So that's our first step. Now, that's not really the question. The question is AD congruent to BC? Well, AD and BC are corresponding parts of those triangles. It's a corresponding segment. So we can say that yes, AD is congruent to BC because if two triangles are congruent, then corresponding parts of those congruent triangles are congruent. So that's how you're going to use that conjecture, is you're going to use it after you prove that triangles are congruent. So you have to prove that the triangles are congruent first before you can use CPC2C. All right, let's look at this last example that's on your note sheet. It says TV bisects angle STU. Is S congruent to U? Well, what does it mean for a segment to bisect an angle? It means that it's going to cut the angle into two equal pieces. So that means angle STB is congruent to angle UTB. All right, that's our first step. Our second step is if you look at this marking right there, that means perpendicular, and this is a line. So if you have a segment that's perpendicular to the line, then those two angles are going to be congruent because the other one they're a linear pair, so they have to add up to 180. And if one is 90, the other one has to be 90. Okay, so now we have angle SVT is congruent to UVT. So that's two angles. That's not enough to prove that the triangles are congruent. So look at those two triangles, and they share that side, TV. So now we have an angle. We have angle STV is congruent to angle UTV. We have a side. TV is congruent to TV because it's the same thing, the same side. It's a shared segment. And then lastly, we have angle SVT is congruent to angle UVT. So that's side, angle, side. So this tells us that triangle STV is congruent to triangle UTV. And again, make sure that your corresponding parts match up. So S and U are corresponding, T and T is corresponding, V and B is corresponding. So make sure that those match up as you write your congruent sign, as you write your congruents of triangles. So now, if we know that those two triangles are congruent, the question is this angle congruent to this angle? Yes, it is, because they're corresponding parts in the congruent triangles. So if two triangles are congruent, then corresponding parts of congruent triangles are congruent. So that's it for lesson 4.6. So please jot down any questions, and we can go over them next time I see you. Thanks.